Today, I want to answer the question, can we define the natural log of a negative number with the complex number system? And the answer is yes. Let's do it. So let's just start with an example of the natural log of negative 7. Okay? So how can we rewrite that? Well, we can rewrite that as the natural log of 7 times, well, we could do 7 times negative 1, but there's another number that equals negative 1. It's not a real number, it's a complex number. That number is I squared. In this case, I want to use I squared. It'll be much more advantageous for us. I squared, okay? So through log properties, right, let's remember that log A times B equals log A plus log B. So we can then say that this is the natural log of 7 plus the natural log of I squared, okay? So let's rewrite this as the natural log of 7 plus, well, let's remember, once again, through log properties, we can factor out the 2, right? So we can change this to 2 natural log of I. Now we're so close to there, but we have one problem. And that problem is this natural log of I. All right, that's preventing us from putting it into the rectangular form. Or is it? Well, we can actually rewrite it in another way, which will be much more advantageous for us and allow us to remove this natural log bit. And what would that way be? Well, let's just remember that e to the I theta equals cosine theta plus I sine of theta. Okay? Now this is our real part and this is our imaginary part. And we want this to be equal to I because we're trying to rewrite I. So if you look on the unit circle and you think, okay, well, when does cosine equal 0, our real part equals 0, and when does our imaginary part equal 1? And if you look on the unit circle, you'll see that our angle is pi over 2. So we can say let's say e to the I pi over 2 equals, well, cosine of pi over 2 plus I sine of pi over 2, right? So e to the I pi over 2 equals, well, cosine of pi over 2 is 0, right? And sine of pi over 2 is 1, so that cancels out to just I. So then we can say e to the I pi over 2 equals I. Okay? So then let's evaluate what the natural logarithm of I is. So we have the natural log of I, right, equals the natural log of e to the I pi over 2, right? Well, the natural log and the e will cancel out, and that just leaves us with I pi over 2, okay? So now that we just figured out what the natural logarithm of I is, we can come back up here and say that this equals the natural log of 7 plus 2 I pi over 2. Now, these twos right here will cancel out, and we'll just get the natural log of 7 plus I pi. So we just went from the natural log of a negative number, right, which is undefined if we stick to just real numbers, and with complex numbers, we're able to define it and put it into rectangular form. But now I ask, can we come up with an equation for whenever we have the natural log of a negative number where we can just put it into that and we get what it equals? Well, yes, and just based off what we've done here, you might already be able to see it. So if we have some natural log of negative x, right? And we're just going to say that your x value is whatever the absolute value of the number that you're trying to figure out the natural logarithm of. So if you're trying to figure out the natural logarithm of -8, right, the absolute value of -8 is 8. So you just have one -8, all right? That might have complicated things further, but hopefully you got that. We can say once again that this equals the natural log of x times I squared, which equals the natural logarithm of x plus the natural, well, you can, let's move a little bit quicker, 2 natural log I, right? We already figured that the natural log of I is equal to that, right? So we have natural log of x plus 2I pi over 2, right? Which equals the natural log of x plus I pi. So whenever you have a negative in the natural log, you can just say that your natural log, right, if it's a -10, the natural logarithm of -10 is the natural log of 10 plus I pi. Thank you so much for watching my video. Let me know if I said anything incorrect or if you have anything additional to add. Have a great day.